Okay, back to the reality of learning Unity. I think I know where we went wrong. I think I know why quit. I quit it so quickly. Um, yeah. I think I should have relied more on the AI so it could sum it up and read it for me, and not rely on my own instincts because I know the basics of C Sharp, but not advanced. And I know I'm going to need to learn more about C Sharp as I go. So yeah, no further ado, let's boot up the hub, the Unity hub, not the other hub you're probably thinking about, you dirty little mind. Anyway, as you can see, I tried to do it on my own before recording, but yeah, failed miserably. So yeah, let's dive in, start up ChatGPT, and let's see where I am now. That's the other one, that's the personal one, okay, cool. This is where we put in the material. Okay, cool. Cool. Player movement, I'm guessing. No. Oh yeah, we're done. I said I wanted to go on my own, but failed miserably. Miserably. Oh, dear goodness. Anyway. At least I got the rigid body up and running, but I think I'm going to let it go step by step, basically. I just want to turn on the docs real quick. Kind of there we go. No viewers currently. That's fine. Do I need stats? No. Yeah. Okay. Cool. What do I want to do now? Wait, I just want to make this thing a bit bigger. Fantastic. Anyway, I just want to pop this thing down. Now, let's listen to the ChatGPT.
Here's how to prepare the player game object for physics interaction by adding a rigid body component. 1. Attach a rigid body component. 1. Select the player game object. In the hierarchy, click on the sphere game object you named player. 2. Add the rigid body component. In the inspector, click Add Component. Search for rigid body and select it to add it to the sphere. 3. Customize rigid body settings, optional. Expand the rigid body component in the inspector to see its settings. For now, leave the default values, but here's what they mean. S determines how heavy the object is. Drag slows the object down as it moves. Angular drag slows down rotation. Use gravity ensures the object is affected by gravity, enabled by default. Disables automatic physics interaction, should be unchecked. Physics gizmos in scene view. After adding the rigid body, you may notice physics gizmos appearing in the scene view. These represent forces and movement related to the rigid body. You can toggle these gizmos by collapsing or expanding the rigid body component in the inspector. Next step, input system installation. Now that the player sphere is ready to interact with the physics system, you'll need to apply forces to move it around. To do that, you'll install the input system package, which allows you to handle player controls. Let me know when you're ready for the installation instructions.
Input system package. Is that why I failed? I'm probably going to need to ask him something after this if this doesn't. Okay.
Organizing scripts and creating the player controller script. 1. Create a scripts folder. 1. Open the project window, locate the project window in Unity. 2. Create a new folder. Click on the Create menu and select Folder. Rename the folder to Scripts. 2. Create the player controller script. There are several ways to create a script. Follow these steps. 1. Select the player game object. In the hierarchy, click on the sphere game object named Player. 2. Add component to create a script. In the inspector, click Add Component. Scroll to the bottom of the Add Component menu and select New Script. Name the script Player Controller. Click Create and Add, or press Enter. Unity will automatically create, compile, and attach the script to the player game object. 3. Organize the script. In the project window, find the newly created player controller script, likely at the root level. Drag the script into the Scripts folder for better organization. Mass 3. Open the script in a code editor. 1. Select the script. In the project window, click on the player controller script to select it. 2. Open the script. Option 1. Double-click on the script asset. Option 2. Click the Open button in the inspector. 3. Wait for the editor to load. The script will open in your default script editor, e.g. Visual Studio. In the next step, you'll write custom code in the player controller script to enable movement for the player sphere. Let me know when you're ready to proceed.
Sorry guys, as you can see my mother is calling me. I'm just going to take a quick break and ask her what's up. with food too. Okay. Boy. Okay. Okay. Excuse me.
Writing the player controller script, setting up movement with rigid body. Here's how to implement the steps for handling input and applying physics to move the player sphere. 1. Declare the onMove function. The onMove function will handle input data to determine how the player sphere moves. Add this method to your script, C# void onMove input value movement value. Get the movement input as a vector2. Vector2 movement vector equals movement value dot get vector2. Create a rigid body reference. To move the player sphere with physics, you need to reference its rigid body component. Add this variable at the top of your script outside any functions C# private rigid body RB. Initialize the rigid body reference. Set the RB variable to reference the rigid body component attached to the player game object. Inside the start function, add C# void start RB equals get component rigid body. This ensures the script knows which rigid body to control as soon as the game starts. 4. Add a fixed update function. The fixed update function is used for applying physics-related changes like forces. Unity calls this function on a consistent time interval. Below the start function, add C# void fixed update. This is where you'll add code to apply forces to the rigid body. Full updated player controller script. Here's what the script looks like so far. C# using Unity Engine, using Unity Engine.input system. Ensure this is included for handling input public class player controller mono behavior, private rigid body RB, void start. Reference the rigid body component RB equals get component rigid body, void onMove input value movement value, / get the movement input as a vector2. vector2 movement vector equals movement value.get vector2. Void fixed update. Add force to move the rigid body to be implemented next. You're now ready to add force to the rigid body in the fixed update function. Let me know when you're ready to proceed with this next step.
Give me a second. I'm gonna ask him the question. Question. You told me I how do I say quote again? I'm guessing that. And I quote, if I need the installation, how do I do that? And do because I am doing it off instructions and excuse me, and well, I have not got okay. I bloody hate. Oh dear me. Okay, this one is just worse. Straight up worse. Okay. Huh. Random thought. Can't wait to get Minecraft Java. Get enough money so I can get Minecraft Java edition. So I can play the Great mod. Can't wait. But for some reason, Microsoft wants me to buy both Bedrock and Java. It's a bit annoying, but hey, anyway. Guys, which one do I need to choose? I'm not sure. Oh damn, this one is a bit longer. And screw it, I'm taking number 2, because it's Well, just in case, because I don't know if I have the package.
Installing the Unity Input System package. To enable your player game object to receive and handle input effectively, you'll need to install Unity's Input System package. Follow these step-by-step instructions to install and set up the input system in your project. 1. Open the Package Manager. 1. Launch Unity and open your current project. 2. Navigate to the Package Manager. In the top menu bar, click on Window. From the drop-down, select Package Manager. Open Package Manager, docs.unity3d.com/upload/package manager window. Nash Doc 2. Locate the Input System package. 1. Ensure you're viewing Unity packages. At the top left corner of the Package Manager window, there's a drop-down labeled Packages. Click it and select Unity Registry to view all available...
Hold on. Error, what the flip? Okay, give me a second, hold on. Okay, let's try that again, shall we?
Installing the Unity Input System package. To enable your player game object to receive and handle input effectively, you'll need to install Unity's Input System package. Follow these step-by-step instructions to install and set up the input system in your project. 1. Open the Package Manager. 1. Launch Unity and open your current project. 2. Navigate to the Package Manager. In the top menu bar, click on Window. From the drop-down, select Package Manager. Open Package Manager, docs.unity3d.com/upload/package manager window. Nash Doc 2. Locate the Input System package. 1. Ensure you're viewing Unity packages. At the top left corner of the Package Manager window, there's a drop-down labeled Packages. Click it and select Unity Registry to view all available Unity packages. Unity Registry, docs.unity3d.com/upload/package manager registry. 2. Search for Input System. In the search bar at the top of the Package Manager window, type Input System. Search Input System, http:/docs.unity3d.com/upmain package manager.
I'm just going to stop it here, right here. Okay. What the... Okay, take a deep breath. Let's begin. Step 2. Go to Window. I did already that. Locate the input package. Ensure you're viewing Unity packages. At the top left corner, Package Manager. This? No. This? No. Wait. Apologies everyone, but for some reason I'm quite retarded. Ensure you're viewing Unity packages. At the top left corner of the Package Manager window, there's a drop-down labeled Packages. Package. Apologies. Let's continue. Click Unity Registry to view all available Unity packages. Okay, I saw Unity registry, so it's here. Oh my word. There is a lot of packages here. I'm quite excited to make my own game. This is just like for learning and stuff. So yeah, okay. Search system input. Probably going to butcher it, so I'm going to copy. Well, input the system I know how to spell it, but you don't know how many times oh, it's installed. Huh. You don't know how many times I needed to use my phone to spell things. Anyway, in the search bar, at the top of the package manager window, type input system. Select the input package. From the search result, click on search as typically published by Unity Technologies. Yeah, Unity Technologies. Okay. Install the system. Click the install button. With the input system package selected, click the install button located at the bottom right corner of the package manager window. Probably that there, yes. I think I got it already because it's saying remove, so let's refresh it real quick. So it's saying removed, so I'm guessing it's already on my package list. Okay. Make installation to complete. Unity will download and install the package. This may take a few moments depending on your internet connection. Nah, fine. I'm on Grandma's Wi-Fi. Just don't question it. Let's continue. Configure the active input handling prompt to enable the input system. After installation, Unity will display the dialog box asking to enable the new input system. Choose input handling mode. Both enables both old input manager and the new system input system. This is useful if you're using assets that rely on the old system. I'm guessing I don't have to enable it because it's already on my computer. Input system package new uses only the new system. Restraints only the old. Okay. Recommendation selects both. Okay. Apply. Click apply or yes to confirm your selection. Unity will start to apply the changes. Save any unsaved work before proceeding. Verify installation. Check that after okay. Open your player controller script to verify it includes necessary name tag, namespace. Yes. Ensure your script can access the new system functionality. Optional. Create an input action asset. Define the manager. Input action ask. Can I ask you a question? Anyway. Okay. Let's continue. To define manage input action like movement, it's difficult to create an input action asset. Create the input action asset input navigate script folder, right click side of folder, click input, create input action, name the asset player input actions. Double click on the player input action, open the input action editor, define action, for example, create an action name moved, assigned, binding like keys or arrow keys. 2. Keys for keyboard input. Generate C# class recommended. The input action editor, click on the generate C# class button. This allows you to reference input action directly in your script via generating class. Note, setting up an input action asset might be covered in the next steps of your tutorial. Why is it so bloody hot in here? Anyway, proceed with scripting the player. Yeah, it's great, I'm going on. Anyway, what's this? The on move function. Okay. Thanks. Let's go on.
Here's the code summary based on the instructions you provided, including adding forces to the sphere and resolving the issues mentioned. Let's go step by step. Updated player controller script. C# using Unity Engine. Using Unity Engine.input system. Public class player controller, mono behavior. / rigid body variable, private rigid body RB. Movement input variables, private float movement X. Private float movement Y. Void start. Get reference to the rigid body component RB equals get component rigid body.
Excuse me.
Void on move, input value, movement value. Get the movement input as a vector 2. Vector 2 movement vector equals movement value dot get vector 2. Assign vector 2 components to movement variables. Movement x equals movement vector dot x, movement y, movement vector dot y. Void fixed update / combine movement floats into a vector 3. Vector 3 movement new vector 3, movement x, 0.0f, movement y. Add force to the rigid body RB dot add force movement.
Okay.
Steps recap. 1. Rigid body variable, declared private rigid body RB to hold a reference to the rigid body component. Initialized it in the start function with RB equals get component rigid body. 2. Movement input variables. Added private float movement x and movement y to store input values for x and y directions. 3. OnMove function. Used input value to get player movement as a vector 2. Extracted x and y components from movement vector and stored them in movement x and movement y. 4. Fixed update function. Combined movement x and movement y into a vector 3 with 0 for the y-axis, vertical movement. Added force to the rigid body using rb.addForce movement. Testing in Unity. 1. Save the script. Save the changes in your script editor. 2. Return to Unity Editor. Unity will compile the updated script automatically. 3. Play mode. Click the play button to test the sphere's movement. Use the input keys or controller, if configured, to move the sphere. 4. Result. The sphere should move, but slowly. Next steps. The sphere is moving slowly because the force being applied isn't scaled to a reasonable value for noticeable movement. In the next step, you'll multiply the movement vector by a speed variable to adjust the player's movement speed. Let me know when you're ready to proceed.
Hold on, I'm just answering someone. And I can't believe I need, how do I spell Excel? Okay, Excel. So, Excel. Apologies, everyone. Yoink. Yoink. Okay. Oh, shit. I think it's moving really slowly. Or it doesn't move at all. Hold on. Player? No, it didn't move. It didn't. it's not moving at all. Yeah, no. Okay. Okay. I'm just going to quickly finish answering this person that just contacted me. Okay. Hopefully. So it doesn't move at all. If I like quit today again, like attempt 1 and 2, I think I'm going to the next attempt 4, I'm going to begin this one because I start to get with Unity Hub. And then explore the Unity editor and this one, because my goodness, my brain is a potato. I don't know why. Okay. But does not move. Doesn't move. Do you think I should go on because we have yes, it has the rigid body attached to it. Yes. Ah, bloody goodness.
If the sphere isn't moving, it's worth double-checking a few things before moving on.
Okay.
Let's troubleshoot. 1. Check rigid body component. Ensure the player game object, the sphere, has a rigid body component attached.
Yes.
In the hierarchy, select the sphere. In the inspector, confirm that the rigid body component is present. Mass, drag, etc. should be default values. Ensure use gravity is checked. Ensure is kinematic is not checked. 2. Input system configuration. Since you're using the input system package, verify the input setup. Player input component. Confirm the player game object has a player input component attached. Check that the actions field points to a valid input action asset. Ensure the input action asset has a move action configured with the correct bindings, e.g.
What? Input system configuration. Player input components, component player attached. Huh. Now you're saying something interesting to me, ChatGPT. What's it? Player input. Oh. Shush. Oh. Lesson. Emma? Hold on. Okay. Okay. Ensure bit check that the action field points ensure so I see, okay. Actually, det wat om te doen, ek is seker of ek action asset. I think I need to go back a bit for just in case. But now I'm here. New action scene. Nope. Well, I unchecked this in the rigid body, so it should probably work. I'm not sure. It works! It bloody works! Oh my goodness. Anyway, but it works! It works! And there it goes. Well, that's short-lived. Well, that was short-lived. Yes, it moves! Oh, man. Hey, anything here? Oh. Hey, views. I guess someone was here. Hello. Anyway. More people than need to quickly answer. Flip sakes. Where's the air? I must say, I feel like a happy chappy now. Second of all, I understand. Good moment. Okay. I understand my concept, but I just fought off. Unity is technically like C sharp. I know C sharp is integrated in Unity, but if you don't check that little box, stuff doesn't work. Stuff doesn't work at all. But now, stuff works. Whee! And it's a ball, like a Bible. Oh dear. Anyway, let's continue. Okay. Anyway. Yeah. Now can't I remember? Oh yeah, move force. That's the movement speed. Yeah, sorry about that. I forgot to tell you.
Great. Let's finalize the player movement by adding and testing the speed adjustment. Here's the step-by-step breakdown. 1. Add a speed variable. In your script, at the top where other variables are declared, add this line, C# public float speed equals 0. 2. Modify fixed update to use the speed. In the fixed update method, modify the rb.addForce line to multiply the movement vector by the speed.
Okay,
C# void fixed update vector 3 movement equals new vector 3 movement x 0.f movement y rb.addForce movement speed. This ensures that the applied force is scaled by the speed variable. Select 3. Save the script and return to Unity. Save your changes in the script editor. Switch back to the Unity editor. Unity will recompile the script. 4. Adjust the speed in the inspector. Select the player game object in the hierarchy. In the inspector, locate the player controller script component. You should see the new speed field with a default value of 0. Set speed to 10. 5. Test the movement. Enter play mode. Use the assigned controls, WASD or arrow keys, to move the sphere. The sphere should now move at a reasonable speed. 6. Adjust if necessary. If the movement feels too slow or too fast, you can tweak the speed value in the inspector. Exit play mode to save any desired changes. If the sphere moves correctly now, you're ready to move on to setting up the camera. Let me know if it's working or if you encounter any issues.
But yeah, I think we need to do more. Oh, that's easy. Anyway, let's continue. So, where other variables are assigned? Probably where all the other public floats are. Where on earth is all my floats? Oh. Finally, I have some coding to do. Anyway, I will put the variable down here. Public float. I think that's all. That's where all are put in. I'm guessing. Yeah. Well, nothing exploded yet, so I'm fine. Hopefully. This. Shit. Okay. Movement times speed. Okay. Now, save your changes to the script editor. Switch back to Unity editor and okay. Anyway, select the player object in the hierarchy. In the inspector, player controller script component, you should see a new speed field with the default value of 0. Set it to okay. So save. Okay. How old is it? Okay, everything's still fine. Well, you should show up in here. Give me a second. I think player controls, I'm not sure. Speed. Oh, okay. Put it down. Okay, let's play. Oh. So that is ASWE, okay. No? W, A, S, and D. Okay. Okay. It just went like, okay. Okay, I feel so bloody happy. Okay. Spears, right. Okay. I think this is like the video script. Yeah, I'm just going to continue. This one is easy. Okay. I just want to go here real quick. Oh. Oh, okay. Cool. Cool. First on the list is this one. It works. Haha. Haha. Ha. There we go. Feel like, whoop, damn. You're rolling now, literally. Oh, ooh, that's awesome. That's awesome. You're rolling now, literally. Setting up player movement is such a satisfying step because it makes everything feel alive. What what's next? Camera setup or something else? Let's keep the momentum going. Okay. Damn, it's like 16:19 now. Damn, okay. And it's so bloody hot in here. Give me a second. Yeah, sorry, my fan is on so you guys might hear it. Okay.
It's awesome that the player sphere is rolling perfectly now. Let's make sure the camera can keep up without rolling into chaos. Here's the plan for the next step. You'll write a new script to associate the camera with the player, but keep it independent of the sphere's rotations. This will give you a smooth third-person view. Next steps. 1. Create a new script. Create a new script similar to how you made the player controller script. Name it Camera Controller.
Okay.
2. Write the script. Inside the camera controller script, you'll calculate the offset between the camera and the player and make the camera follow the player without inheriting its rotations. 3. Attach the script to the camera. Add this script to your main camera game object.
Okay.
Let me know when you're ready, and we can start writing the camera controller script.
Okay, bud. I press new, yes, new script. I name it camera controller. Press enter. There's the script. Now, just waiting for the assets to load in. Assets to load in, and then I can go to assets. I probably don't need this one, so I'm just going to delete it real quick. There we go. Okay, here's camera control. I'm going to put it into scripts in there. Okay, now let's begin. Man, I feel great, but yet so dumb because I had the whole holiday to work on this, but now holiday, and now it's almost school time, and I'm all, and I am. Leo, just shut up. Okay, cool. Well, I'm on my own.
Great. Let's go step by step and implement the camera controller script for a smooth player following camera. Here's how the script should look and the steps to follow. Step 1. Create the script. 1. Select the main camera in the hierarchy. 2. In the inspector, click Add Component and name the script Camera Controller. 3. Move the script to your Scripts folder for organization. Step 2. Write the script. 1. Open Camera Controller in your script editor. 2. Add the variables and logic as described. Here's the complete code. C# using Unity Engine, public class camera controller, mono behavior, public game object player, reference to the player. Game object private vector3 offset, offset value void start. Calculate the offset between the camera and the player. Offset equals transform.position, nice player transform position, void late update. Update the camera's position to follow the player transform.position equals player.transform.position plus offset. Step 3. Attach the script. 1. Save the script. 2. Back in Unity, ensure the main camera has the camera controller script attached. 3. Drag and drop the player game object from the hierarchy into the player field in the inspector for the camera controller script. Step 4. Test the script. 1. Hit play to test the camera movement. 2. Move the player sphere using the controls. The camera should follow smoothly, staying in the same relative position and ignoring rotations. Next steps. If the camera is working as expected, congratulations. If you encounter any issues or the camera doesn't behave as expected, let me know and we'll debug it together.
Well, let's see. I hope it works. Not sure. Unassigned reference expectation. The variable player of camera control has not been assigned. You'll probably need to assign the player variable to the camera scope. Unassigned reference explanation. Players. No. Great. What's the thing's name again? Copy. Paste. No. Oh dear me. So what? Okay. problem. I just sent the problem. Problem. Okay.
The error message you're seeing, unassigned reference exception, indicates that the player game object has not been assigned to the player variable in the camera controller script in the inspector.
What?
Steps to fix the issue. 1. Select the main camera in the hierarchy. 2. In the inspector, find the camera controller component. 3. You should see a field labeled Player under the camera controller script component. 4. Drag and drop the player game object from the hierarchy into this player field. This assigns the player object to the script, allowing the camera to follow the player properly.
Okay.
Once done, click play again, and the camera should follow the player without errors. Let me know if you encounter any more issues.
Well, it works. It works. Okay, cool. Oh yeah, how far did I got today? I got the movement done, I got this done. I need to do a lot of the... Well, not really that far gone. Just need to do 1, 2, 3, 4, 5, 6... 6 more to go. Fantastic. What?
It sounds like you've successfully created the reference to the player game object and set up the camera. Now, the camera follows the player without rotating as expected. Well done. Next steps. Now that the camera is working correctly, it's time to move on to configuring the basic play area. Here's what you might want to do next. 1. Create boundaries. Set up invisible walls or boundaries to prevent the player from rolling off the map. You can use simple colliders like box colliders or mesh colliders to create these boundaries. 2. Add obstacles or platforms. Consider adding platforms or obstacles the player needs to avoid or navigate. You can use simple shapes like cubes, spheres, or custom meshes for this purpose. 3. Lighting. Set up lighting to create the mood of your game. You can adjust the direction of the light, intensity, and color. 4. Test the play area. Test the movement within the newly configured play area to make sure everything is working smoothly. Let me know when you're ready to dive into any of these steps or need help setting up your play area.
Thanks, I'm going to take a break for the day. That was amazing. I'm so glad that I got the player movement done. Oh my word. Wow. So yeah, I'm done for today. Thank you for whoever just looked by and went. Anyway, bye.